Hello dear students, today we are going to start our next lecture in standard 9th science that will be based on our e-learning classes. So welcome to the Vdvs Vidya Sankul's e-learning classes. We are going to start our second lecture in the motions chapter. Okay, but before we going to start our next topic in this chapter, let us take a brief preview on what we have studied in the earlier in this chapter. Okay, so let us begin what we have studied in the earlier chapter. Let us take a recap on that chapter. Okay, so far we have studied about what is the motion. So in which we have seen that if an body moving across an any point or if an any body movement, okay, that can be predefined as the motion. Afterwards we have seen that what is the types of motions. In that we have seen about the two types of motion, in which we have seen the uniform motion and non-uniform motion. But this is the subtopics of the types of motion. We have seen, so far we have seen the topics regarding the types of motion, in which we have seen the straight line motion, circulatory motion and a regular motion, which will be called as the periodic motion. So that is the study we have already finished in this chapter. Afterwards we have started about the distance, and now we are going to start about the distance. In previous lecture we have seen the lots of extracurricular activities regarding the motion, and also we have seen the lots of regarding the topics. Okay, now we are going to start our first topic for today's lecture, that will be distance. Okay, so introduction we have seen, in which we have seen the basic definitions regarding the motion. We have also seen what is the rest position of an object. Okay, if the body doesn't move at all with any reference point, that can be considered as it will be in a rest position. Otherwise we can say that the body will be continuously moving. Okay, next point we have discussed that types of motion, in which we have seen the translatory motion. It will be called also as a straight line motion, in which we have studied about if an object travels across the straight line from one place to another place, that can be called as the translatory motion or a straight line motion. So for that we have seen the example, like if I traveling from here to here, that can be considered as a translatory straight line motion. Okay, if a train or if a bus moving from one place to another place in a straight line path like that. For example, suppose a train travels from A point to B point. So if we draw that diagram, then the motion will be considered as a straight line motion, because it is also making a straight line. So that's why it is considered as a straight line or translatory motion. Okay, afterwards we have seen about the rotational motion, in which we have seen about what is the rotational motion. So if an body or the object travel across and comes back to that place like that. Okay, suppose if an body travels from here and comes back to that place, okay, then this motion will be called as the rotational motion or a circulatory motion. And last but not the least, this is the periodic motion that we have seen in the pendulum. Okay, when an object comes back to that path and doing the same path of the motion, that can be considered as the periodic motion. Okay, going on a next topic, that will be the linear motion, in which we have seen that if the word linear means a straight, and we have seen the word motion means a moving of an object or change in the object. Okay, we have seen that if this is the example of the straight line motion. So if a man running on a straight line, that can be considered as a linear motion. So it is crossed the path in a straight line or in a linear way, so that can be considered as a linear motion. Okay, so this is the important topics that we have already seen in the previous lecture. Going on the first topic regarding today's lecture, that will be uniform motion. Okay, so these are all the important topics because we have to study that. Okay, and this is the important points, and we have to memorize it and we have to learn that. Okay, because in day-to-day life we can also see the motions around us, the universe also moving, okay, the whole body is moving, okay. So all of the things that are continuously moving, so for that we need to understand this topic very well. Okay, now if a body covers equal distances, now what will be the uniform motion? As earlier I have told you that two types of motion will become in this chapter. First one is the uniform motion and another one is a non-uniform motion. So in a first uniform motion we are going to see that topic. If a body covers equal distances along a straight line in a regular intervals of time, then the motion is said to be uniform. Means whatever what they have told us, that if a body, suppose I am a body and I am traveling across a path and I am covering equal distances. So for that I have to explain you that if I am traveling and I have covered a 5 kilometer of distance in a 5 minutes, and another 5 kilometer distance in another 5 minutes. In another 5 kilometer I have taken also a 5 minutes of time. So I have covered the equal distances in a equal time. So that makes us that what am I doing? That I am doing an uniform motion. For that the time and the distance of the interval will be remains same. Otherwise what happened? The motion will not go on a straight line. So these graphs shows us that what happened when a body travels in the uniform motion. If the graph will be not visible to you, I am explaining that graph, okay. Here you can see we are looking forward to the distance time graph for the uniform motion. Now what I have told you, that equal distance in equal time. This is the important point, you need to memorize that and you need to write that point because it is considered in a uniform motion. That is the way you can understand the uniform motion. Otherwise the problem will be created in your mind. So for that I need to plot a graph. Now what should I take to draw a graph? First of all I need to take the two axes. Okay, as you know, one axis will be defined as the x and another will be defined as the y. So this is the x axis as we know and this is the y axis. Now we have to take the two quantities to draw the graph. And which are that quantities that we want and we needed to draw the graph? Okay, so these are the quantity like distance and time. You can see here it is a distance and the time. These are the quantities. In next topic we are going to see about what is the distance. But before going on there, we have to look at what is it. Okay. So time and a distance we have to plot on a x-axis and y-axis. Now what should I put on a x-axis and what should I put on a y-axis? So for that I need to put time on the x-axis. Okay. Here I am drawing you. What should I have to draw? Here I have to draw the time. And what should we write on the y-axis? Then we should write the distance on the y-axis. That can be also called as the another marker I am taking so that you can see. Distance time graph. Okay, you can see that it is also known as the distance time graph. Now whatever the quantity written first, it can be placed onto the y-axis, or in other words we can memorize that by the x-axis always represent the time. Now I have told you in the earlier lecture, each and every quantity must be represented on it's based on its units. Okay, so for that we have understand that time is defined by t and its unit, or we can say that SI unit will be second and it will be defined as the S. We know that in the previous lecture. Okay, now I am putting the times value, so in a 5 seconds, in a 10 seconds, in a 15 seconds, or in a 20 seconds. Okay, now here I have traveled 5 minutes and here I am writing the distance, okay, only 10, 50, 20. Okay, now what have I done? I have done the motion in 5 minutes in a 5 kilometers in a 5 minutes, so that will come the point here. Okay, it will represent the point here. Afterwards I have covered the 10 kilometer of distance in a 10 minutes, so the point come here. Afterwards 15 kilometer of distance, then the point come here, and this the 20 kilometer of distance, then the point will become here. So if I join this line, then the motion of that line means that the straight line motion is defined as the uniform motion. Okay, this is defined as that the uniform motion is like that whenever an equal distance will be covered in the equal interval of time, it is predefined as a uniform motion. So as per the name, you can very well understand what is a non-uniform motion. Okay, another topic will become as a non-uniform motion. Okay, so it will give us that unequal intervals of time in unequal intervals of distance in unequal intervals of time will be covered. Unequal time and unequal distance. Then this will be defined as the non-uniform motion. Okay, so for that, if I want to memorize the definition, then what should I have to write? Then whenever an body or an thing or an object will be traveling across and it will cover unequal of distance in unequal interval of time, that can be said as a non-uniform motion, or otherwise we can say that it is a not doing uniform motion. So those objects or those bodies who are not traveling in the uniform motion, we can say that it is doing a non-uniform motion. Okay, so non-uniform motions basic definition will become afterwards. Afterwards we are going to see about what is the uniform motion. Okay, we have to see the graphs regarding that. But before going on there, we need to take a notes from here. Okay, so if you want to take a notes from here, you can pause the screen here and you can take the screenshot here. Okay, so what am I supposed to do? I am giving you a seconds of time that can give you how can you take the photograph of it. Okay, now going on our next topic, that will be non-uniform motion. Okay, but before going on there, I am erasing this. Okay, so that you can understand and you can go to the next topic. Okay, now I hope you all understand how to draw the graph and what the graph represented to you. Okay, otherwise what happens, you cannot understand the graph, and whenever the graphs come, your brain will be doing a headache. Okay, first of all, I am going to show you the slide, and afterwards what we are going to do, then afterwards we are going to doing a non-uniform motions graph that we have drawn like the uniform motion. So here are the uniform motion. As you can see here, this is the same graph that we have drawn here, but in this the case will be different, in which they have given us the 15 minutes of time, in 15 minutes of time, the body or the object travel 10 kilometers each. Okay, like that, the 10 am to 10:50 am, it means the interval will be 15 minutes and the distance travel is at 10 minutes. Afterwards, the distance, the time interval will be also 15 minutes, the distance travel another 10 kilometer. Afterwards, another 15 minutes and the distance travel 10 kilometers. So you can see that the time intervals remains the same, distance will be covered as same, and if we draw the graph, then it will become on a straight line graph. So this graph and this motion will be known as the uniform motion. Examples are given here. If a ball pushed in a free space will continue to move uniformly, covering equal distances, equal interval of time along a straight path. This will explain us that if a ball, what happened to the ball? If a ball where we have thrown in the space means out of the atmosphere of the earth. Okay, whenever we cross the layer of the atmosphere from the earth, it will give us the space. So whenever going on a space and then we push or then we throw the ball into this space, then what it happens to there? The ball traveling across in the circular motion or in orbital structure of the earth without and it also covers the equal interval of time in equal interval of distance without doing any harm to us or without doing harm to itself also. Okay, and continuously moving from one place to another place. So we can say that if we can throw the ball into the space, then and then only this type of motion can be happen. Okay, otherwise you can take the example for as whenever you are traveling on a bike or whenever you try traveling across some vehicle, then you can traveling on basis of that. If you are traveling the bike, then you can add at the 5 minutes of distance, and whatever the distance you have covered, you can measure it. Okay, afterwards we are gonna see about the so like that you can measure the distance and you can measure the time interval regarding that. Now going on the next point, that will be non-uniform motion. So what happened in the non-uniform motion? I have already told you that the unequal interval of time covers the unequal intervals of distance covers in a unequal intervals of time, that can be considered in a non-uniform motion. Okay, so going on there, I am explaining you the graph regarding that. Okay, so we are going to see about the graph regarding the non-uniform motion. Okay, so first of all, what I need to draw? I need to draw the two graphs or the two axes that represents the graph. First axis will be x-axis and another will be y-axis. So for the non-uniform motion, it also needed two things. Non-uniform motion also needed the two things, that will be also a time and distance, because it is also covered the unequal distance and unequal time. So we have to draw the time and the distance onto. So what should I have to draw on the x-axis? That I have to draw time. So first 5 seconds, then 10 seconds, suppose this 50 seconds and 20 seconds. Okay, we are gonna like that. And this represent the time and this represent the distance. Now in a 5 minutes, okay, let us write here the distances. Okay, but I am not drawing you and I am not telling you that I have covered the 5 kilometers of distance in a 5 minutes, not like that. I am just writing the distance here, not the covering distance of my object or my body. Okay, now what happened if I travel 3 kilometers in a. We are going to see now about the non-uniform motions graph. Okay, let us take the non-uniform motions graph. So first of all, we need to take a distance and a displacement like we have taken in the uniform motion. For that, I need to put these two quantities on a graph that will be drawn like that. See, here I am representing the x-axis as the time, and here I represent the y-axis as the distance. Now what am I doing here? That I am giving a 5 minutes, 10 minutes, 15 minutes, 20 minutes of intervals of time. Here I am also doing a 5 kilometer, 10 kilometer, 15 kilometer and a 20 kilometer of distance interval here. Okay. Now suppose what we have talked about earlier, that what is a non-uniform motion? That whenever I cover the unequal intervals of distance in unequal intervals of time, that can be represented as the non-uniform motion. So first we are going to understand what happened when I travel 5 minutes. When I travel 3 kilometers in a 5 minutes. Okay, so point comes here. Then what happened when I travel 10 kilometers in a 10 minutes? Then the point will come here. Now in a 15 minutes I have covered the 20 kilometer of distance. Okay, then the point will come here. And now on a 20 minutes means afterwards a 5 minutes of gap, I will come back to the 15 kilometer. And then the graph point come here. Now whenever we are joining this line, the graph comes like that. And as you can see that, if you remember that, what is the uniform motions graph I am drawing here? This is the uniform motions graph. So it is covered in a straight line. Okay? It is look like that. This is the uniform motions graph. While this is the non-uniform motions graph. Okay, you can draw it from here. Okay, if you want to draw that, there is a 2 seconds of gap I am giving here. Okay, there is a 2 seconds of gap I am giving here, and you can draw it from here. Okay. As you can see, this is the basic difference regarding the non-uniform motion and the uniform motion. Okay. As you can see, this is the straight line path and this is the curved path, or we can say that it is the curved line path that can be represented by the non-uniform motion. Okay. Now we are going to see the based on the non-uniform motion. Okay. So now what happened to the non-uniform motion, that okay, it will gives us the uniform motion and this will gives us the non-uniform motions graph. Okay. So if you want to see the slide clearly, then therefore I am erasing that. Okay, as you can see, if a body covers unequal distances in unequal intervals of time, then the body is said to be in a non-uniform motion. Examples: the ball takes the curved path whenever we throw into air. Suppose for that we are going to understand that example. For that, what am I doing here? If I take a ball and I throw it into the air, what happened to that? Whenever I throw the ball, it comes in a fast motion, but suddenly it reaches some point there where it comes in a downward position, or it came back to the earth surface by the gravitational force will pull the ball towards its surface. So that can consider the ball speed will be now increasing whenever it reaches the earth's surface. Okay, so whenever the ball comes back to the earth, its speed will be, or its distance will be covered more fastly than it going from here to the upper side of the layer. Okay, so whatever this we have to understand that, and after going on that we can see that it is a non-uniform motion. Now in the next topic we are going to see about the physical quantities. On our next topic, that will be the physical quantities. Okay, so as we have seen when we start this chapter, we have seen that what is the physics and what are the some of the quantities that we are going to study in this chapter, or that we are going to study in the physics portion. And that will be the study regarding the quantities which we can understand it but we cannot feel it or we cannot see it. It will become in a physics portion. Okay, so in that physical quantities there are two subcategories are divided, like scalar quantities and vector quantities. Now we are going to study about the scalar quantities, in which we are going to see about what is the scalar quantity in the physics. So the quantity which we can represented by its only a magnitude, it can be considered as the scalar quantities, while the quantities which we want to represent, then we needed a two kinds of thing, that will be the magnitude and the direction both. And whenever we needed the both to represent any quantity, then it will be considered as the vector quantity. Going on a scalar quantity first, as I said you that what is the basic definition regarding the scalar quantity, that if an quantity represented by only a magnitude, okay, I am writing here only magnitude, means what? First word came to your mind, that what is magnitude? Magnitude means some numbers. If I can represent it and if I can explain you a quantity just by giving a number to you, then if you can understand the quantity by easily, then you can say that the quantity is known as a scalar quantities. Okay, for example, if mummy goes to the bazaar, then what mummy said to the shopkeeper, if she want to buy a mangoes or if she want to buy apple, then mummy will say that please can you give me a 2 kilograms of mangoes, can you please give me a 3 kilograms of apple. Then the shopkeeper will accept it, and shopkeeper will understand that what is your mummy is saying, that I want to give her a 2 kilogram of mass of mango to you. Then the shopkeeper will also understand, and then your mummy will also understand, you can also understand. But what am I saying, that it is only represented by the numbers. Okay, so it only needs the magnitude that will consider, and that will be, we can conclude it and we can understand the quantities by which it. Okay, so mass is the quantity which we can understand by only a magnitude. Okay, but have you ever heard that your mom is going on a bazaar and said that can you please give me a 2 kilograms of mango in a north direction? Have you ever heard like that words? Okay, no, mommy will not say it, and you also not say it, because the direction is not necessary to represent the quantities. Okay, mass quantities. Okay, direction is not necessary to represent the mass quantity. So for example, we can consider the mass. Okay, so mass is the quantity which we can define as the scalar quantity. Now going on a vector quantity. So what is the vector quantity? The quantity which we can represented by magnitude and direction.